greatest integer function is not necessarily a function I want you to master. Let's see. I want you to be exposed to. Okay, so we're looking at exposure, not necessarily test questions, quiz questions on it, but at least that you see. Okay? So how many of you have been to Defy Gravity? Okay, a few of you. Okay? Perfect example of a step function is the pricing rate at Defy Gravity. So in Defy Gravity, if you want to go to also jumping or a dodgeball, if you want to pay for 30 minutes of jumping time, you pay $8. Then for 60 minutes, it's $11. 90, 14, 120 is $17, and then every additional 30 minutes is $3. Okay? So let's look at what that would look like on a graph. So when we are, and you don't have to graph this out, just watch this, but when we are not jumping at all, we're not going to jump even 1 minute, we decide we back out and so forth, they'll refund us our money, right? So at 0 minutes, we're not paying for anything, are we? But at 1 minute through 30 minutes, how much do we pay for? 8. Okay, so we want to be $8 until we get to 30 minutes. And then at 31 minutes, what happens? Now it becomes 11, right? So at 31 minutes through how long? Through 60 minutes, right? So here we're not paying, here we are. At 30 minutes we're not paying, but 31, anything above 30 we are, up to 60. And then what happens? Yep, you pay $14, it steps up. So when you're at 60 minutes you're not paying 14, but when you hit 61 minutes you are through 90 minutes, right? And then what happens? $17, and then I run out of space, so I can't show any more of this, but open circle here through 2 hours. And I don't know how anybody jumps on a trampoline for more than 2 hours and has any legs left, so that kind of isn't the realistic end of it, right? Okay, this is called the step function, okay? The function that you're looking at is going to be called the greatest integer function. And we're just going to look at a few problems with these. The greatest integer function is noted with a bracket and absolute value kind of symbol nested together. So when you see that weird symbol, that means the greatest integer function. And the greatest integer function is defined as the greatest integer less than or equal to x. So the greatest integer function of x is the greatest integer less than or equal to x. So now we have to figure out what we mean by integer. What are integers? Whole numbers, no decimals, no fractions, right? Both positive and negative, including 0. Okay? Our counting numbers, including the negative counting numbers. So some of these will seem too simple. The greatest integer less than or equal to -2 is -2, because -2 is an integer, right? The greatest integer less than or equal to 3/10 is 0, because 0 is an integer that is the biggest one less than 3/10. The greatest integer less than or equal to 1 6/10 is less than or equal to 1 6/10 is 1. Okay? We want to round up. It's natural, right? But think of this as rounding down. Does that make sense? Okay, kind of almost truncating. So this will be 1. And the negatives are what are going to mess you up. If we really think about this. What is the greatest integer less than or equal to and negative 2 and 4 tenths. Negative 3, because negative 3 is the greatest integer less than or equal to negative 2.4, 2 tenths. Negative 3 is less than negative 2, right? And you can see this in action. Someone has created a greatest integer function on Geogebra. So if we go there, oops, apparently my link is not working. There's the single cap, not double. And here we go. So let's scroll down a tiny bit. So that one we just looked at was what, negative 2 and 0.6, right? So easy enough when we're up here. 2.67 is 2, 4.35 is 4. Those are pretty easy to figure out. When we get to those negatives, we have to actually think about what's going on. When we're at negative 53 hundredths, what's the greatest integer less than or equal to negative 53 hundredths? Negative 1. When we're at negative 2 and 67 hundredths, the greatest integer less than or equal to negative 2 and 67 hundredths is negative 3. Okay? Does that make sense? All right. Back to PowerPoint. So, where it gets interesting is when we ask you to evaluate f of x, where it is the greatest integer of x plus 3. So tell me, from yesterday in your discoveries and your exploration and your review of parent functions, what is this plus 3 going to do to that function? So one person doing the function aerobics without even meaning to. What's it going to do? Move it left 3, okay? So everything here will be shifted left 3. Make sense? Okay? So let's evaluate. When we want f of 5, that means that we're finding the greatest integer function, the greatest integer less than or equal to 5 plus 3. What's the greatest integer less than or equal to 5 plus 3? 8. F of negative 2. We'll say the greatest integer less than or equal to negative 2 plus 3. That will be 1. F of negative 2/3 is going to be the greatest integer less than or equal to negative 2/3 plus 3. What's negative 2/3 plus 3? 2 and 1/3. So the greatest integer less than or equal to 2 and 1/3 is 2. And finally, we want to plug in 5/2 to our function. So we want the greatest integer less than or equal to 5/2 plus 3. 5/2 is what as a decimal? 2.5, right? Okay, 2.5 plus 3 is 5.5, right? And when it comes out of the greatest integer function, it will be 4. Make sense? You've never been exposed to this. This is simply an exposure thing. I'm not necessarily going to ask you to graph a step function on a test or a quiz, right? But I want you to see it, because there are real life applications to these types of problems. Make sense? All right. Not necessarily taxis, because you get charged a rate. Actually, yeah, it could be taxis. Mileage, there's mileage there, but there's Uber, I think, would be another one that would be a step function. very similar to the greatest integer function. I think you pay a certain amount per mile. Okay? All right, so just a few short questions that we didn't, it's on your syllabus for yesterday. Wasn't sure if we'd have enough time to get through everything, so it's also on your syllabus today. Okay, and then we're going to talk about some things from section 1.7, which is what we're on our way, what we were talking about with parent functions and so forth yesterday. So